Woo. Exponent time. All right, we're doing some exponents review with integers. Next time we'll tackle the fractions, you know what I'm saying? So we're going to take one step at a time. But as a quick review here of exponents, and I have a feeling this is going to be exponentially fun. That was good. When we're multiplying with like bases, we add the exponents. So for example, if we had x squared times x to the fourth, we would get x to the sixth. We would add the 2 and the 4. When dividing, we subtract our exponents. I'm going to change colors. I'm going to get gray right now, new color. If I had x to, say, the 7th over x to the 3rd, I'd subtract the 7 and the 3, giving me x to the 4th. I'd also like to point out, what if we had something like the other way around, x cubed over x to the 7th? Well, then I'd have 1 over x to the 4th, 1 divided by x to the 4th. Make sure you don't just subtract and then also, oh, it's not in the denominator anymore. It's got to be in the denominator in that case. Awesome. Power to a power. Let's get a new color here. It's gonna be fun. I'm gonna go blue. Let's see here. So if I had something like x to the 3rd raised to the 4th, in this case, so there we go. It's a little better 4. You know what? I'm gonna fix that 4. There we go. I'd have x to the, well, what's 3 times 4? That's x to the 12th. Cool. Now, if you're ever wondering on a few of these properties here, especially when we're talking about the multiplying and the power to a power, if you were to write out x squared times x to the 4th, you would have x times x for the x squared, and then x times x times x times x for the 4th. That's 6 x's written out, hence why we have x to the 6th. This could be written out as x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd, right? 4 times because of the 4th power. And then if you were to expand it even further, like we just did for multiplying, we'd have 12 of them all lined up, hence the x to the 12. Whoop, whoop. All right, negative exponents. We do the reciprocal, flips upside down, right? So if I had, in the same fashion here, let's continue. I'm going to go orange now. If I had x to the negative 5th, I'd have 1 over x to the 5th, 1 divided by x to the 5th. Excellent. Wonderful. And one other thing that I do want to add here is anything to the 0 power is going to be equal to 1. So if I had x to the 0, that'll be 1. All right? So maybe jot that down. If we go to the 0 power, it equals 1. That's great. So anytime you're in panic mode of exponents, think back to these 5 rules that we have written down here now with the one that I added. All right? If you're stumped, think, okay, well, what can I do? Is that legal, what I'm doing? Is that maneuver legal, what I'm about to do here based on my 5 rules that I have? And then try the problem again. And that's easier said than done, but take some practice. Let's hop to it. All righty. Got some numbers to work with first. 8 to the negative 2nd. Well, what did we say if we had it raised to a negative power? We would do the reciprocal, right? We'd flip it. So we'd have 1 over, 1 divided by, I almost went right to the answer, 8 squared. So if I have 1 over 8 squared, that's going to be equal to 1 over 1 divided by 64. Boom, there's the first one. I like it. Excellent. The next one, holy cow, I got 2 numbers, 3 over 4. Well, reciprocal, right? Flip it around. So I'm going to have 4 over 4 divided by 3 squared, and then I'll distribute this exponent in. And remember, it's like we have 4 to the 1st and 3 to the 1st. So 2 times 1 is 2. That means that it's going to be 4 to the 2nd, which is 16. And then I'll have 3 to the 2nd, which is 9. And there's my final answer. I could write out all those steps, but this is review. This should not be anything new. Okay, so we can simplify our step writing. I'll go with a new color here so we don't get anything mixed up. Negative 3 to the negative 3rd. My goodness, we're just throwing negatives all over the place. Well, first I'm going to do the reciprocal. So I'm going to have 1 divided by negative 3 to the 3rd power. Now, negative 3 to the 3rd power, if we have a negative number to an odd power, it will retain its sign, so it'll still be negative. 3 to the 3rd is 27, so I will get 1 over 1 divided by 27. Negative 27. My goodness. Whew. Almost missed that one after I said it. Okay, so good to be careful here. Case in point. Last one. All right, I have this negative power, so I could do the reciprocal right off the bat. But I'm noticing that when I eventually distribute this -2, it's going to go to this 5, which then if that's in the, I'm going to have to bring it. It's going to be a lot of shifting around. So I think what I'm going to do to attack this one, and there are different ways to go about these problems. What I'm going to do is I'm going to distribute to both of these. Remember, there's like a 1 right here in front of the 5. That's a real squiggly 1, but it's hard to write on this thing sometimes. So I have 5 to the -2nd, because 1 times -2 is -2. 5 to the -2nd. And then I have x to the +6th. So notice how I get a positive exponent here. So that x to the 6th will stay. And then I'm going to have x to the 6th divided by 5 squared, which is 25. So I can just write that right there. Whoop, whoop. Awesome. So far, so good. Bueno. So whenever we see like exponents, like this 8 to the n, 3 to the n, 4 to the n, we start thinking like, oh, can I just like multiply those because they're all the same? Then I'll multiply all the numbers together and it'll be great. Like for example, with numbers, we'd have 3 times 2 is 6 and 3 times 3 is 6. Can we do that? No. When we're multiplying with like bases, we can add those exponents, right? 3 plus 3 is 6. I think I said 3 times 3. Sorry. When we have like bases, we can add the exponents. That's not the case here. We don't have like bases. However, if you notice what we did here in this problem, we distributed the 2 to the 4 and to the 3. Over here, I distributed the -2 to each part as well because it was all multiplication or, in this case, division. What if I were to undistribute it, right? Take it out. So what I'd have then is 8 times 3 over 4, all of this to the power of n, to the nth power. Now I would have 8 times 3 is 24 over 4. And I would get 24 divided by 4 is 6 raised to the n. All right, there's my final answer. So I can't just multiply the bases and add my exponents because they don't have like bases. It's a different case, and it's an easy thing to stumble through and make a mistake on. So in this case here, what I'd actually have if we're dealing with the numbers is that I would have 3 times 2 cubed, right? I wouldn't add the 3 and the 3 to get 6. So now I have 6 to the 3rd, which indeed is 216 as we see right here. That does end up working out. Otherwise, we get something totally different. All right? So definitely a solid thing to jot down so you don't make that mistake. Moving on. Alrighty, some more examples, and we're just going through some of the tricky ones because this is a review and we're trying to hit those difficult problems. So first one, we have x to the -3rd times x to the 5th plus x to the 3rd. Well, what can I do with that? These are all like bases of x, so I can go ahead and just distribute into that binomial. So x to the -3rd times x to the 5th, I would add my exponents because they're like bases, and I'd get x squared. And then I'd have -3 plus 3 is x to the 0. And what did we say about anything to the 0 power? It is 1. There we go. Nice and simplified. So when we're simplifying, we mean no negative exponents and then reduce if possible. Okay? Lovely. So let's look at this one here. Yeesh. We got negative exponents on the inside there. We got squared. You know, I think some people might be tempted to distribute that exponent of 2 there, but that's a binomial. You cannot do that. You'd have to FOIL it, and that just sounds terrible as well. But what about this? We said anything to a negative exponent, we could do the reciprocal, right? We could flip it. So perhaps I could rewrite it as 1 over 5, 1 divided by 5, minus 1 divided by 10 squared. Now, I have 2 fractions being subtracted. I could get a like denominator, a common denominator, like so. Now I can subtract these. So now I have 1 divided by 10 squared. Piece of cake now, right? 1 squared, 10 squared gives me 1 divided by 100. So I'm going to distribute that exponent in. I'm going to square the 1. I'm going to square the 10. Bingo, bango. Awesome. Cool. I'm in a color switching mood here. I'm going to go back to green. All right, next one here. We have 6x to the 3rd minus 4x to the negative second over 2 divided by 2x to the negative fourth. Now, since I have one term in my denominator, a nice little strategy here would be to split this fraction, okay? And then we can simplify individually. So what I'm going to do is rewrite this as 6x to the third divided by 2x to the negative fourth minus, because of this bad boy right there, 4x to the negative second over divided by 2x to the negative fourth. All right. Now I can simplify individually. I like that. Give myself a little more room here. So I have 6 divided by 2 is 3. And then I have a fraction here. So I'm going to subtract 3 minus negative 4 would give me x to the 7th. Lovely. Then over here, I'm going to have 2 in my numerator because 4 divided by 2 is 2. And then I have x to the negative second divided by x to the negative fourth. So negative 2 minus negative 4 is positive 2. Numerator is where it goes. If you're ever wondering where it's going to go, as far as like where your x is going to go when you're subtracting, you're dealing with negatives, or even when you're not dealing with negatives, wherever the larger one is where it goes. 3 is larger than negative 4, so it's going to be in the numerator. It's going to end up there. Negative 2 is a larger number than negative 4 because we're dealing with negatives here, so it's going to end up in my numerator. We are good to go on this one. I'm a fan of it. I like it. I'm ready to keep going because this bad boy over here, woo, yeesh. Again, a negative, ugh, terrible, right? No, we can handle it. First thing I'm going to do is I'm going to do the reciprocal here. So I'm going to have 1 over 1 divided by 4 plus, and you know what? Since we have already done this a couple times, I'm just going to flip this one right there to be 1 over b. Actually, you know what? On second thought, I'm going to keep it like this. Okay? Because if I can simplify what's inside the parentheses there, and it becomes a fraction, which I imagine it will because of the 1 over b, I can just do the reciprocal at the end. So let's go that route. Okay? So I'm changing course right away, which is something that you might have to do with these exponent problems if you get stumped. Okay, so I'm going to get a like denominator, so it'd be 4b over b plus 1 divided by b, all the negative first. So now I'm going to have 4b plus 1 divided by b to the negative first. And what can I do now? Reciprocal, woo woo, b divided by 4b plus 1. And we can leave it like that. There are no negative exponents. I cannot simplify this any further, so I am done with this problem. That is fantastic. Don't you think so, Jenny? You may wonder why Jenny isn't in this video yet. It's because there's a thunderstorm, and she is a little bit scared, so she's hanging out there in her thunderstorm spot. But, you know, she's good. Okay, let's keep going. All right, a couple more wonderful examples with negative numbers, negative exponents. Man, it's just we're throwing them at you because you can handle it. Okay, you can handle it. So for this one, again, I have just a single term in my denominator. I'm going to split it because that's generally a wonderful, easy way to go about it. Easy, you know, being relative here. So y to the negative first divided by y to the negative first plus 1 divided by y to the negative first. Well, anything divided by itself is just 1. And then over here, since it's 1 divided by negative, or 1 divided by y to the negative first, I can just bring it to the numerator, and it becomes positive y. So a problem that looked kind of scary wasn't that bad. There are other ways to do this one, and it can get pretty nasty, but I think this is the cleanest way to go about it. So there you go. There's a few ways to do it, but that was the quickest. So for this one here, there are a couple ways to look at it, and I'm going to show you 2 things here. I'm gonna go green again. I'm just feeling the green. All right. So I have x to the negative second. I have x plus x to the negative first. Now, initially I'm thinking, well, maybe I'll do like 1 over x squared, 1 divided by x. You know, get rid of those negative exponents. But I'm also thinking, can't I multiply a fraction, numerator and denominator, by the exact same thing? That is okay to do, yes? I can multiply it by 5 over 5 if I want. I can multiply it by 1,000,000 over 1,000,000, and it will remain equivalent. What if I think about my exponent properties, where if I multiply something with like bases, right? These are all like bases. If I multiply it with a like base, I would add my exponents. So what is my most negative exponent here? It's x to the negative second. What if I were to multiply my numerator by x squared? It would get rid of that negative exponent, right? It'd become x to the 0, which is just 1. Well, I'd have to then multiply my denominator by the same thing so that it's equivalent. And in doing so, I'd end up with x to the 0 divided by x to the third plus x. Because negative 1 plus 2 is 1, so x to the first. And then finally, I'd have 1 divided by x cubed plus x. There are no further simplifications I can do here. I am done with that problem. All right. Sometimes it can help to look at it in a slightly different way. If I were to rewrite it as 1 divided by x squared over x plus 1 divided by x, well, now I can think of this, and maybe I'll throw this over to 1 so we're dealing with fractions and fractions. I can multiply by my least common denominator, which would be x squared. So if I multiply by x squared here and x squared here, perhaps you might see the simplifications a little bit better. X squared times this one gives me x squared over x squared, which is 1. And then x squared times this guy would be x to the third over 1, so x to the third. And then times this one, I get x squared divided by x, which is just x. It results in the same thing. Perhaps you might see it better in this one. I honestly prefer this one myself, but I know different people see it in different ways, so I wanted to show you both to get to the same route, or get to the same answer. Alrighty, another little math trick of the trades. Simplifying using common bases. So let's check out this first example. We have 2 to the 8th, 4 to the negative 5th, and 16 to the negative 1st. You may notice that all of these can be written with a base of 2. And here's what I mean by that. We have 2 to the 8th. 4 could be written as 2 squared to the negative 5th. And 16 could be written as 2 to the 4th. And we still have the negative 1st. So now everything's the same base, which makes it a little easier to simplify. We'd have 2 to the 8th, and then 2 to the negative 10th over 2 to the negative 4th. And now I can combine my numerator to be 2 to the negative 2nd divided by 2 to the negative 4th. And then lastly, we would have to subtract our exponents. Negative 2 minus negative 4 is negative 2 plus 4, which would be 2. And since my larger one is in the numerator, it's 2 squared, which equals 4. I am done. Bingo, bango. Awesome. Excellent. That's all by hand, right? We would expect you to do this by hand without a calculator. You could find something like this on a no calculator portion of a test or SAT. Who knows, right? So be ready for this without a calculator. Next one, feel free to pause it and try this one. Use what we just used here, and then I'll go over it. Did you pause it and try it? Because you should. Okay, let's go for it. So 25 and 125 and 5 all can be written as a base of 5. So I'm going to have 5 squared to the third. And I honestly like to write it out like this. I don't like to just go right from this to this step. I think it's easy to make a mistake, so I think it's nice to write out 5 squared in parentheses, then deal with your exponent property of multiplying those. I just find that to be helpful and to mitigate any mistakes. Then I have 5 to the n over divided by, this is 5 to the third times 2 minus, or sorry, raised to the 2 minus n. So now what do we do? Well, let's deal with, we got 2 times 3, right, because it's 5 squared raised to the third, so our exponent property would tell us to multiply those, and I'd get 5 to the 6th, and then I'd have times 5 to the n divided by, and then I'd multiply these, so I'd get 5 raised to the, well, it's 3 times 2 is 6 minus 3n. Lovely. I'm going to give myself a little more room over here. Well, what do I do in the numerator? If I have multiplying like bases, I would add my exponent. So when you're in these situations, you're like, there's so much happening. What do? I feel like this, especially this right here, is one where you're like, I'm in panic mode. What do I do? I've never seen a binomial and an exponent. Who does that, right? Well, I know my exponent rules tell me if I have a power to a power, I want to multiply them. So that's what I did. 6 minus 3n. I just said to distribute the 3. Boom. We're good. Go back to those 5 main rules. All right. So now, like bases in the numerator. 6 plus n. Done. Who cares if we have a binomial in the exponent? We're following the rules. I don't make the rules. I'm just following the rules, right? I'm just a good math person. And then I have 5 to the 6 minus 3n. Oh boy, I have binomials in both exponents. I don't know what to do. Oh wait, let me go back to my basic rules here. When I'm dividing with like bases, what do I do with my exponents? I'm going to subtract. So let's subtract them. And if you'd like, feel free, do a little side work. 6 plus n minus 6 minus 3n. Don't forget, it's a terrible 3 there. 3n. Don't forget to distribute that negative. So I'd have 6 plus n minus 6 plus 3n. Yeah. All right. So my 6's cancel, and then I'm going to have 4n. Bippity bop. Just don't stop. Woo! 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 I like that one. That was fun. That was fun. Jenny also agrees, but again, she's still hiding out from the thunderstorms. It's scary stuff for a dog. All righty. We got time for one more? I think we got time for one more. All right. Negatives galore. Yeesh. 3 to the negative first plus 6 to the negative first, all raised to the negative second. Don't even think about distributing that negative 2, okay? Because this is a binomial. You can't distribute an exponent into a binomial. That's a no-no. Perhaps, I'm going to start on the inside by writing it like this. 1 divided by 3 plus 1 divided by 6, all raised to the negative second. Perhaps I could get one fraction inside there by getting a common denominator. What is that going to be? Well, I'd have 2 divided by 6 plus 1 divided by 6, all raised to the negative second. And now I've got 3 divided by 6 raised to the negative second. What's 3 divided by 6? That's 1/2. Oh, man, I love these simplifications. I love when things work out like this. It doesn't always, but sometimes it does. All right, I'm going to flip it, do the reciprocal, which gives me 2 over 1, or just 2. And then I would change my sign of the exponent to a positive. I've addressed the negative exponent by doing the reciprocal. I have 2 squared, which is 4. That's it. I know that got intense there. Those are some difficult problems. I hope you guys enjoyed it as much as I did. Clearly, I enjoy this far too much. But you guys have a wonderful day. America, freedom, rock and roll, Costco. Riverdog Jenny still hanging out here. You gonna do all right, Jenny? All right. Make sure you follow her on the gram. Riverdog Jenny on the gram. Have a wonderful day. Deuces.